Potentiometry. Potentiometry is used to measure the electrical potential of a reaction. This method is commonly used to analyze the concentration of ions in a solution. Voltammetry. Voltammetry is used to measure the current generated by a reaction. This method is commonly infrared, IR, spectroscopy is a powerful analytical technique used to identify and quantify the chemical functional groups in a sample based on the interaction of light with the sample. This method is widely used in various industries, such as pharmaceuticals, materials science, environmental monitoring, and forensic science. How infrared spectroscopy works. Infrared spectroscopy is based on the interaction of infrared radiation with matter. When a sample is exposed to IR radiation, the molecules within the sample absorb certain wavelengths of IR radiation that correspond to the vibrational modes of the chemical bonds in the sample. Each chemical bond has a unique vibrational frequency that is determined by its mass and the forces between the atoms in the bond. By measuring the wavelengths of IR radiation absorbed by the sample, we can identify the types of chemical bonds and functional groups present in the sample. Types of infrared spectroscopy. There are two types of IR spectroscopy: Fourier transform infrared (FTIR) spectroscopy and dispersive IR spectroscopy. In FTIR spectroscopy, a beam of IR radiation is passed through a sample, and the resulting spectrum is analyzed using Fourier transform algorithms to generate a high-resolution spectrum. In dispersive IR spectroscopy, a beam of IR radiation is passed through a prism or grating to separate the different wavelengths of radiation, which are then detected by a detector. Applications of infrared spectroscopy. Infrared spectroscopy is widely used in various industries for the analysis of organic and inorganic compounds. Here are some examples of its applications. Pharmaceuticals. Infrared spectroscopy is used to analyze the purity and identity of pharmaceutical compounds, such as active ingredients and excipients. Materials science. Infrared spectroscopy is used to analyze the composition and structure of various materials, such as polymers, ceramics, and metals. Environmental monitoring. Infrared spectroscopy is used to analyze the composition of atmospheric pollutants, such as carbon dioxide, methane, and nitrous oxide. Forensic science. Infrared spectroscopy is used to analyze trace evidence, such as fibers and paint chips, in forensic investigations. Advantages and limitations of infrared spectroscopy. Advantages of infrared spectroscopy. Non-destructive. IR spectroscopy is a non-destructive technique that can be used to analyze samples without damaging them. High sensitivity. IR spectroscopy can detect small amounts of sample, making it useful for trace analysis. Wide range of applications. IR spectroscopy can be used to analyze a wide range of samples, from organic compounds to inorganic materials. Limitations of infrared spectroscopy. Limited to functional groups. IR spectroscopy is limited to the analysis of functional groups and cannot provide information about the stereochemistry of molecules. Requires sample preparation. IR spectroscopy requires samples to be prepared as thin films or dissolved in a suitable solvent.